port. Port means what? Port is a pair of terminals. Pair of terminals through which signal here, the signal means it may be voltage, may be current. Signal can enter or leave. Port is a pair of terminals through which signal can enter or leave. See, the signal means what? It may be a voltage, may be a current. Consider one network is like this. Consider this is some network. Here we can see we have a pair of terminals. We have plus minus. I can say this is voltage V if I say, and here this current is entering into the network. The current will go in the entire network and will return back. Yeah, this is the I. And here whatever the current that is leaving from the positive terminal, the same current will return to the negative terminal. Right. So here how many ports we have? Port means what? A pair. Here, so what I should call this is here we can call this as a one port network. This is called as a one port network. A pair is called as a one positive, negative is called as one pair. That is a one port network. Consider we have a network is like this. For this network, let us consider we have a terminals like this. Now here this is one pair and this is another pair, isn't it? If I call this voltage is V1 and this entry current is I1, and here the whatever current is leaving from the positive terminal, the same current has to return to the negative terminal. That is a law of conservation of charges. If I call this voltage is V2 and this entry current is I2, whatever current is leaving, the same current has to return now. This is I2 is returned. Now what I should call this is this I can call it as a two port network. This I can call it as a two port network. And now consider we have some other network is like this. How a network is like this. This is my network. I have a network is like this. Now here how many ports we have? More than two we have, isn't it? Now this is one port, positive, negative, let us say. This is another port, and here this is another port, and this is another port here. So here this is a 4-port junction, like this we can say. So this type of network, if the network contains more than 2 ports, then we can call it as a multi-port network. multi-port network. Multi-port network. This examples for multi-port network is a in the electronics fellows will study in the multi-port networks in the microwave engineering. They might study about the E-plane T, H-plane T, magic T, hybrid T, directional coupler, circulator. All those are the examples of a multi-port networks. Now our complete focus is about what it is a two-port networks. Means this type of networks only now. Now here we'll talk about only the two-port networks here. And these two-port networks this is my network. We are considering the two ports. This is the port 1 and this is the second port. Plus minus this I can say V1 and this current is I1 I can say. The same current has to return to whatever the current is leaving, the same current has to return. And this is the second port. If I apply some other supply V2 and this current I can call it as I2, the same current will return I2. Right, now we can see here in these two port networks. Here you can see how many variables we have here. How many variables we have? That is V1 I1, V2 I2. Totally how many variables we have? 4 variables we have. How many variables we have? 4 variables we have. From these 4 variables, what we do is we'll select at a time, we'll set 2 as independent variables and the remaining 2 as a dependent variables. We will select at a time 2 will take it as a independent variables. Two as a independent variables and the remaining 2 as a dependent variables. 2 as a independent and remaining 2 obviously will become say dependent variables. Now you tell me now, so in how many waves I can select 2 independent variables from this 4? How many ways we can select now here? I can say 4C2 now, the selections I can do. I have totally 4 we have. Among these 4 I need to select the 2 as a simultaneously we need to select now. 4C2, how much is 4C2 now here? 4 into 3 by 2 into 1. So how much is value? 6. That means there are this totally 6 different combinations are possible. How many combinations are possible? 6 different combinations are possible. So those things we are going to see now. The 6 different parameters we are going to see. Yes, before that we'll see one important definition, that is classification of symmetrical network. Symmetrical network. When we can say given network is symmetrical or asymmetrical. Yes, the ratio of excitation or response, both are same. Excitation to the response at one port is same as the ratio of excitation to the response at other port. You can say, if I can write, if the ratio, then the network is said to be symmetrical network. And the network is said to be symmetrical network if the ratio of excitation to response at one port is same as the ratio of excitation to response at other port, then the network is said to be symmetrical network. Means this is my network, the two-port networks. Our complete discussion is about the two-port networks, right? So here, let us say here this excitation is V1, and so the response is I1. In this port 1, excitation is V1, response is I1. Then what are they seeing? The ratio of excitation to response at port 1. What tell me the ratio of excitation to response at port 1? What I can say here? V1 by I1. This is the ratio now. Yes. Now tell me the ratio of excitation to response at another port. If I say this is my V2 and there is a current I2, I can say. Now tell me the ratio of excitation to response at another port is a V2 by I2. If it is same, then the network is said to be a symmetrical network. The ratio of excitation to response at one port is same as the ratio of excitation to response at another port. Right. This is a condition was symmetrical. One more thing, a reciprocal network. Reciprocal network means simple, as we have earlier we have seen. The network which obeys the reciprocity theorem, I can say. Reciprocity theorem. Then the network is said to be a reciprocal network. Previously we have seen a reciprocity theorem. If the network satisfies the reciprocity theorem, then we can call that is a reciprocal network. Now means consider this is the network. If I say port 1 and this is port 2. This is V1, I1, this is I1, this is V2, this is I2, and this also I2. Reciprocity theorem means what we have seen previously, the ratio of excitation to response. Yes, if I apply the V1, now this is my I2 is my other port we need to consider now. I can say, so what is this ratio we can say here? V1 by what? Response to excitation to response. When we apply supply voltage V1 and this I2 is my response, now here I2 I can write. That must be same as when you apply the V2 is the supply excitation. Now this I1 is my response, that is V2 by I1. If a network satisfies this property, if it is satisfies V1 by I2 equal to V2 by I1, then the network is said to be what? Reciprocal network. Right? And the conditional symmetrical is what? V1 by I1 is equal to V2 by I2. And here V1 by I2 is equal to V2 by I1. Then we can call the network is a reciprocal. Fine. With this we'll see some. We have seen that totally how many parameters are possible here? 6 parameters. So let us discuss one by one parameters in detail. So what is the different type of parameters? We'll discuss one by one in detail. We'll discuss. See this thing. Consider one by one parameters here now. Let us discuss about the one by one parameters. The first one is the first parameters. I'm calling it as a jet